Hello, you're watching Studio Ken. Make sure you don't miss any episode of Studio Ken by subscribing to the YouTube channel. To subscribe, search for Studio Ken on YouTube, click subscribe on the bottom right of your screen, and set a reminder. You can also watch Studio Ken on Diamond TV on Wednesday at 18:30 and on Saturday at 19 hours. Studio Ken, the home of Kennedy Gondwe on YouTube.
Greenwashing or renewable energy? That's the question one immediately would want to ask on hearing that tires are being turned into fuel. On one hand, making diesel, gasoline, and other fuels from unused tires that litter homes, markets, and even the streets is certainly welcome from the perspective of cleaning up the environment. On the other hand, the process of greening up these tires is not so friendly to the environment. Does the benefit outstrip the downside? Today on Studio Ken, we are featuring an ambitious Zambian entrepreneur whose company has started making fuel from disused tires and plastics. A civil engineer by academic credentials, Mulenga Chiku Mulenga is the founder and director of Central African Renewable Energy Corporation.
Hi, my name is Leah Banda. I'm a certified coach and speaker. You're watching Studio Ken. Don't forget to subscribe.
Mulenga, welcome to Studio Ken.
Thank you very much, Ken.
Is the production of fuel from old disused tires and plastics a concept just on paper, or it's already happening?
No, it's not on paper. It is something that is very much happening, and we are in full production currently.
Of course, at some point to see that happening. But Zambians still remember a story of a man who came here and claimed that he would produce fuel from grass. Nothing, no single drop ever came out of there. Why should people trust you?
Well, I remember that story too, though I was much younger. But I think the dynamics that were used then are totally different from today. And like I've said, we're in production. So it's not only drops that are there for you to see. It is the actual fuel in form of diesel and petrol that you are able to see. And this is a product that is able to run in a motor vehicle. We've tested it several times. We've shown it on camera. People have been able to see it. So it's not an illusion. It is something that is real.
How did this start? How did the dream get birthed?
Well, we are a company called Central African Renewable Energy Corporation. It was incorporated in 2015, and our focus was to look at forms of renewable energy. We tried to look at the solar space, but then that did not fit well into the type of business we wanted to do. So we turned to recycling, and we were trying to see what we could do in order to provide or to get the best recycling processes and methods and materials out of the recyclable materials. That is how we then, through research, stumbled upon this technology called pyrolysis, for which we then decided to improve on it, and we were able to produce the diesel and the petrol that we're producing currently.
Is it something that you saw somewhere, or it's just an experiment that went right for you?
Like I've said, the process of pyrolysis is open technology. Anyone can check it up. You can even look it up on Google.
Yeah, but I've hardly seen people that produce fuel from rubber, from plastics.
Exactly. It's because of the dynamics behind it, you know. So we decided to push the limit. We're coming from an engineering background, and as engineers, we seek to provide solutions to humanity's challenges. And this is one of the solutions that we're able to provide.
So take me through the process from the time that you collect the tires until such a time that you produce the fuel.
Okay, what happens is, you see, we have a lot of this waste rubber and plastic around, which is polluting our environment. So we are contributing by helping clean up the environment by collecting all these tires from the various places into central collection centers. Once we get these, we get them onto different trucks and be able to transport them to our plant in Shantumbu. Once the used tires or the plastics get to Shantumbu, we cut them up into reasonable chunks or sizes that are able to fit in the reactor for which we then load into the reactor. Our reactor is able to take in up to 1.5 tons of rubber or material at any one given time. So we load this, close the reactor and make sure that it's airtight, and we introduce heat in there. So we actually heat the material that we've loaded in there, and once it heats up, it then forms a gaseous solution, which we then mix with a certain chemical formulation, which is obviously our secret. And this is where all the science happens and all the mathematics in there happens, such that when these two components, the material that is burning and the chemical that we have meet, they then form what is the petroleum which we are producing, which we later on separate through a process of condensation into diesel, petrol and gas. So that by the time you are looking at the tanks that we have there, the material automatically separates itself into those three products.
You talk about the importance of cleaning the environment of all these products such as rubber. But at the same time, one might argue that in as much as you are doing that, you are also introducing another hazardous process through the gases that you produce.
Well, we are doing a process in a controlled environment. Controlled in the sense that we do not release any gases into the environment.
At all?
Of course, we are producing LPG, which at the moment we just have to burn it out so that it goes out. But in future, with the expansion program that we are doing, even this gas is going to be contained such that we are able to have make use out of it properly. We have issues where we're able to package it in the gas canisters, and then we'll also be selling that. So really, in terms of environmental pollution, we are helping clean the environment and not really polluting the environment, because even during our process, you will see later on as we go on a conducted tour that there's very, very little smoke or any emissions that come out of our process.
Who's approved all this that you've been up to?
It's a bit of a tricky question, because everything else we have been doing currently in terms of production of fuel, we don't have regulation for. And currently we are engaged with government through the various agencies so that regulation can be formulated in order to support this projects that we are running.
Why isn't there regulation?
Those are answers that the agencies would best. No one has ever thought of. Have you ever thought of manufacturing petroleum, petrol, for instance? No one ever thought it could even be done. Even now, people don't believe that this is possible, it can be done. So normally you find that laws and regulations are made for things that are current. If you remember, I just want to give you a very quick example that for a long, long time, we had no law that governed internet and the cyberspace until it came. And then that is when there was a law that was put in place. So I'm pretty sure that now that we've come on board as Central African Renewable Energy Corporation, there will be a law that is going to govern the production of petroleum in this country.
To the best of my recollection, you are the only Zambian. I've not heard of any of this, even in Africa, maybe across the world. What are you doing to patent your formula?
So many people have asked us about patenting this formula, and we are in the process. It's not as easy as anyone could think, or even as easy as we thought. It is actually a process. It starts from PACRA, then it goes to a patent office in Zimbabwe, which looks at the African heritage. From there, it has to go to some patent office in the UK. And then you have to patent in the specific regions where you want this patent to be applicable. So it's a complex thing, and we are working on it. It's not something that can be done overnight and boom, you've got a patent, but we're getting there.
From what you're explaining to me, much as all this involves science and all that, it also sounds like a very simple process. Can technology make it faster than what you are currently doing or experimenting? Technology is obviously improving every single day, and
we have improved on a certain technology that we found and been able to convert this into something that is commercially viable. Once this stage passes, we'll be looking at how we can then improve the processes that we are using. So definitely, as we go on, there's definitely going to be improvement in production processes and production times.
Do you have any theoretical and practical experience into petrochemicals or engineering?
Well, I've got a civil engineering background. It's obviously not the same as petrochemical engineering, but out of interest and out of wanting to find solutions for the so many challenges that we face in this country, that is how come we took interest. And I personally took interest to be able to study the bit that I have studied so that we're able to produce what we are producing.
Which is what? One knows you or may know you as a civil engineer, but from what I've gathered, there's a lot more that you've done other than that field.
I've studied civil engineering, obviously. I've studied business management. I've studied entrepreneurship up to master's level. I've also studied finance and accounting. So even sometimes people ask me, what are you? It's not an easy question to answer. But obviously when people hear that, oh, he's an engineer, it sounds prestigious. So I choose to be called an engineer. But obviously I'm carrying a lot more than just engineering in my bag.
Carrying a lot more than just engineering in your bag, but you chose this particular side of things. Why?
It's what tickled. You see, when we go to school, school is there to open up your horizons and broaden them up. I think we've also discovered that if probably I was in some developed country and this is done, the following day I'll be called a doctor, because then I would have done a novelty in terms of being able to produce something. And that is what education is all about. We go to school in order to open up, in order that we might apply the knowledge that we learn into practical situations. And that is exactly what we have done.
So what exactly are you producing other than fuel, other than petrol and diesel, and in what quantities?
We currently have a small plant which is producing up to 600 liters of diesel, petrol, heavy fuel, oil, and gas as well. Every batch that we run. So we're producing that every day.
Have you tested your products on any car?
Yes, we have. We've tested them on the Land Cruiser 200. We've tested it on the Nissan. We've tested it on the Mitsubishi. We've tested it on the BMW. We've tested it on the Golf, and so many other vehicles. And these are our vehicles which we've been testing on the last 2+ years now. And so far, we would say we've had no problems. Further than that, we've also taken the production, or our production, to the lab with Zambia Bureau of Standards. And it has tested positive for petrol and diesel. And those results are there for anyone to see. They can even go to the Zambia Bureau of Standards and find out on their own.
From the time that you tested 2 years ago up to this point, one would have expected that your production would have really ramped up, but you still seem to be in the formative stages.
The reason is simple. It's not as easy as you were saying, and like anything else that you're doing, it takes time to be able to develop and be sure. There are some times that people have developed products, and 1 minute they'll tell you they've developed a product. The next minute you are being told that no, that product was taken off the shelf because it wasn't good enough or because it couldn't stand the test of time. So we have taken this long to ensure that the product that we have is really a good product, and it is a product that is going to work. If we're going to test fuel in a motor vehicle and we're testing it for 2 years and your motor vehicle is still running, it means we've done it. And that's why now we're talking of an expansion program. We want to be able to produce up to 1.5 million liters of diesel and petrol combined every day.
Okay, what challenges have you faced along the way? This is something that's happening for the first time. In as much as people can be excited, there are also those that will be skeptical.
Challenges, to begin with, you see, we are African, and we think from the negative side of things. And every time when we started off this project, Everyone just said, "You're mad. This can't happen."
It's not only an African thing. I mean, anyone.
No, I'm talking about the environment I've been exposed to.
Yeah.
Okay, because I'll tell you, this same project, when I took it elsewhere and was doing my research, because not everything that has been done and researched has been done locally. Where I took it to, people said, "Oh yeah, okay, you've got something here. Oh yeah, we can be able to do this." We'll, you know, that sort of enthusiasm is not here, not even within the engineering fraternity. People are used up to today, we're still building the same way, we're still copying the same things that have been done over and over. And I want to call and challenge all the engineers in this country. We've got learned engineers, we want to call them technocrats, in various fields. Let them come up and show us what they're able to do. It's not just about doing something that was done by somebody else in a book and you keep quiet and you call yourself an engineer. No, no, no. That's not what engineering should be.
But for you at least to have reached this stage, you've also received support.
You've asked me about the challenges that we have faced. Firstly, it's been criticism, okay? Especially the first days, because really no one believed in this project. Not even the local team I was using to build the plant that we're building, you know? So it's hard enough when you're doing something and no one believes you and everyone says, "Hey, you're just mad," you know? So that has been a huge challenge. And because of that, this project that we have done, we have spent something like $250,000 now, okay? It has taken time for us to be able to raise that money. If it were in other places where people take such innovation seriously, that should have taken us no time to be able to raise, okay? Financing has been an issue, but luckily we've had an angel who's been financing our project through and through, and he's also happy that he's seeing results now. We're seeing light at the end of the tunnel. Challenges also in terms of, I've spoken about regulation. It hasn't been easy because it's not there. We have regulation for production of biofuel, ethanol, I think, or something, all those things, but not the actual petroleum. So you find certain things that we would want to do and bring them to light. For example, I would want to sell this fuel. I need to get a license from ERB to be able to sell the fuel. But then if they have not certified my, given me a license for production, they'll be saying, "Where have you gotten this fuel from?" So it all starts from there. It's a ring. So those are some of the small challenges, but I'm happy now that most of these challenges are being tackled and being resolved and sorted out.
What has been the driving force behind you? What has been your fuel for you to reach where you are?
First thing is criticism, of course. You know, every time somebody says, "This you can't do," my mind tells me, I've got to prove them wrong, okay? And then it's belief in what we have done. I've told you we're coming from an engineering background. I'm a civil engineer. So I have interest to build things. And this is something I've always had from childhood. I can actually tell you that my young brother and I, my young brother Lombe, we actually made a bicycle at one time that used a tube, rubber, as a chain. And that worked. And these were small boys. I think I was in grade 6 or 7. He was in a much younger grade. And we have grown up like that to be able to try and build things. So that is what drives us. Even when people don't believe in certain things, we believe. I believe personally as an engineer, if I set my mind to doing something, there's got to be a solution for it. And that is what drives me.
So not until you reach a stage of selling what you are producing, where are you taking your fuel at the moment?
I'm using it. My friends are using it. My relatives are using it. Okay? So at least we're able to prove. And this, anytime anyone that has used it on a voluntary basis can testify that they have used this product and it's a good product and it has not killed any of their machinery.
What next after this in terms of your production?
We're actually quite in discussions with quite a number of international organizations that have indicated their willingness to partner with us so that we can expand this project. We have already done our designs for a plant that is able to produce 1.5 million tons of fuel every day. So we are in that process. As you know, it's not as easy as just drinking water for you to be able to ramp up from a project of this size and get it fully a commercially viable project. So what next is we're in the expansion phase now.
Scaling up.
We're scaling up.
Other than the challenges that you described to me, and you obviously talking to international partners, what kind of support are you receiving from the government, the private sector, locally?
Locally, government, I'm glad that government is seriously coming on board now. I should say kudos to Engineer Kapala, who's our current Minister of Energy, and our current Minister of Commerce, Honorable Chiku Mulenga, who as ministers heading these different ministries have actually taken interest, and we have engaged with them, or they're engaging with us, to see how best we're able to then develop this product and make sure that this product or this project is something that brings value to the entire nation of Zambia.
Do you see this as a viable business?
It is, and that is why you have all these international organizations coming into Zambia. I can tell you confidently that we have one company that's from Canada that's already sent its representatives here to come and see this project and discuss the way forward for this project. And we have some more partners who are coming into Zambia very soon in the next few weeks. As we are speaking now, we have keen interest from the government of Burundi. We have people that are coming in from Uganda this week who are coming to look at the same project. We're discussing with some South Africans, we're discussing with so many other nationals from different places. These have seen that this project is viable and it makes business sense. That's why they even want to come and partner with us.
What does that say then about the quality of the fuel you're producing for you to be able to attract all these partners? How does it compare with what we import?
Far much better, much more superior.
In what sense?
Our sulfur levels. Most of us talk about low sulfur diesel. Low sulfur diesel, everyone wants to put low sulfur diesel in their vehicles. Our national standard for low sulfur diesel is 0.5 parts per million, okay, or ppm, which is I think around 500 parts per million if my mathematics is correct. What we are producing is not 0.5. We are producing 0.046. We're not even getting to 0.1. We're doing half of 0.1. Okay.
You've lost me there, but of course I think the people in the sector understand.
What we are producing is ultra low sulfur diesel. Okay. When we are talking about petrol, just to get a little bit more technical, you have the research octane number, you have the motor octane number, and you've got your sulfur content as well. I hope I'm not twisting this. Research octane number, our national standard is I think 88, and research or motor octane number is 91. For the one which is at 88, we are getting as high as 95. Okay, for the one which is 91 as our national standard benchmark, that's what we have here. We're getting as high as 97, 99. Not even Indeni produces that kind of fuel to put on the market. So this is fuel that is good enough for a racing vehicle in Europe. That is what we are producing, and that's how good it is.
And other than the fuel, you're also into some core production, or you're doing something?
Oh yeah, that's another very interesting project, which we actually, as of last week, were able to confirm that we are able to produce diesel from coal. We've got millions and millions of tons of coal. A lot of people have asked us about sustainability on the tire side in terms of tires. I've always said, as long as we human beings are there, we shall always generate waste in terms of waste tires. Furthermore to this, we have now confidently developed or been able to manufacture or produce diesel and heavy fuel oil from coal. We have millions and millions of tons of coal lying around. And this is what most of the industries are using. We have steel industries, we have cement industries, we've got the mines. They're using coal heavily. In as much as there's been talk about coal polluting the environment, we are saying, no, wait a minute. We're able to get something clean out of this. And we've been able to produce diesel from coal. And I want to urge everyone that doesn't believe this, even all these cooperating partners that are there in this country, to be able to engage us so that they are able to see, gentlemen, what is it you are doing? How can we be able to support you in all this that you are doing? Because what we are doing is not just for ourselves. This is something that is a national treasure, so to speak.
And of course, ladies are involved. You just said gentlemen.
Of course. We have a lady engineer on our team. She's a chemical engineer. Very sweet lady, very sweet young lady, fresh from school, but very brilliant.
Excellent.
Yeah.
All the best, and I can only look forward to a day where I'll come with my car and put in some free fuel.
Of course. Well, you'll be one of our trial partners.
Thank you.
All right. Welcome to our plant in Shantumbu. This is Central African Renewable Energy Corporation. This is a plant where we manufacture diesel and petrol from waste rubber and waste plastics. Behind us here is our production facility, which I shall be taking through you through the production processes. I think if you can come with me. What we have here is our reactor, and this is where we load all our used tires, in which we burn them or heat them in a controlled environment at the temperatures up to 400 degrees Celsius. So you will see, if you come with me here, the whole reactor. I've got 2 towers there. This is ideally my control panel. This is what controls all the whole system that is here. Okay, so we switch on the equipment from here and switch it off from here. In those 2 towers there, what I have is a catalyst which is loaded in there, and then I've got 2 temperature gauges there also, which we use to be able to control the manufacturing of the fuel, depending on what temperatures we are getting. After all that, we hit, everything goes up in there, and then it passes through and comes to this chamber here. Normally, this chamber is very hot. This is our condensing unit. This is now what separates the fuel that we make from the gas, the petrol, and the diesel. When it comes from there, we use, to condense this, we use water, which we run here. This is cool water, which we use to cool this whole condensing unit so that we are able to collect our fuel. Normally, once the fuel starts producing and coming out, the fuel comes into here and then comes and discharges through here and then into these tanks. We control this tank, either it goes there or it goes here, depending on what we are collecting, whether it's fuel or whether it's diesel or petrol. As you can see here, the tank is already getting filled every time it's producing. You have a bit of fuel and this will come up to the top. When it reaches the top here, then we know that we have collected fuel. The gas that is collected comes through this pipe into this tank, and then we let it go out through there and we burn it. The reason we're burning this gas is at the moment we do not have the facility that needs to be able to load this gas into containers, as this, for this size of plant, was uneconomical. So in the next plant that we are coming up and doing our expansion phase, all this gas that we produce here will be collected and put into gas cylinders, and we'll be able to sell it to those people that want to use it for uses like cooking and industrial uses like welding. Beyond here, what we have here is a burner which burns everything else that we load in the reactor there. This small machine, small as it looks, is able to burn all this material up to as high as 400 to 500 degrees Celsius. And then after which, all that thing, when it burns, it melts inside, it forms a gaseous solution which we mix together with the chemical formulation that we have loaded in our towers there, and then it comes this way. So that is how we produce this fuel that we are producing here.
Hi, my name is Leah Banda. I'm a certified coach and speaker. You're watching Studio Ken. Don't forget to subscribe.